Hello and welcome to day 22 of Advent of Code 2024. So today the puzzle is called Monkey Market. And so let's look at this problem. So as you are all teleported deep into the jungle, a monkey steals the historian's device. And this is also a reference, of course, to an earlier year of Advent of Code. So it was 2022. The monkeys kind of appeared 2 times that year. So they steal the historian's device. You get it back while the historians are looking for the chief. So the monkey that stole the device seems willing to trade it, but only in exchange for an absurd number of bananas. And your only option is to buy bananas on the monkey exchange market. You aren't sure how the monkey exchange market works, but one of the historians senses trouble and comes over to help. Apparently, they have been studying these monkeys for a while and have deciphered their secrets. Today, the market is full of monkeys buying good hiding spots. Fortunately, because of the time you recently spent in this jungle, you know a lot of good hiding spots you can sell. If you sell enough hiding spots, you should be able to get enough bananas to buy the device back. On the market, the buyers seem to use random prices, but their prices are actually pseudo-random. So, as pseudo-random is kind of it's not actually a totally random number. It's kind of a deterministic random number that you generate with kind of a specific seed and a specific under specific rules. So that's why it's called the pseudo random number. Yeah. So if you know the secret how they pick their prices, you can wait for the perfect time to sell. The part about secret is literal. The historian explains each buyer produces a pseudo-random sequence of secret numbers where each secret is derived from the previous. In particular, each buyer's secret number evolves into the next secret number in the sequence via the following process. So you calculate the result of multiplying the secret number by 64. Then you do a process called mix, which mixes this result into a secret number. Finally, prune the secret number. Then you calculate the result by dividing the secret number by 32, round the result down to the nearest integer, then mix the result into the secret number. Finally, you prune the secret number. And then you do the last step is kind of multiplying the secret number by 2048, then mix this result into the secret number, and finally prune the secret. So mixing is that you calculate the bitwise XOR of the given value and the secret number. Then the secret number becomes the result of that operation. I give you an example here. So, and to prune the secret number is actually just to calculate the secret number with a modulo operator to this specific number. Then the secret number becomes the result of that operation. So after this process completes, the buyer is left with the next secret number in the sequence. The buyer can repeat this process as many times necessary to produce more secret numbers. So here they kind of give an example of what happens when you take 1, 2, 3. You do this process with it. So the first sequence will be this number. Then you take this number and take it through the same process. You will get this number, and so on. So each buyer uses their own secret number when choosing their price. So it's important to be able to predict the sequence of secret numbers for each buyer. Fortunately, the historian's research has uncovered the initial secret number for each buyer. So this is the kind of the list that we should use, because this is the example list. So this list describes the initial secret number of 4 different secret hiding spot buyers on the Monkey Exchange market. So if you can simulate secret numbers from each buyer, you'll be able to predict all of their future prices. So in a single day, buyers each have to have time to generate 2,000 new secret numbers. So in this example, for each buyer, their initial secret number and the 2,000th new secret number they would generate is this then. And adding those numbers up produces this result. So that's what we are going to do. So in our sense, we're just gonna actually get this example input here in our file. So we will kind of do our normal parsing. So we will have our lines, which will be our file read all lines. Yeah, not the input. So we will do the test input. Yeah. So so we will kind of what we want to do is kind of calculating a total. So we have a total which will be 0, and this will kind of eventually be a long number. It will not. I mean the number for these few test examples will not be a long number, but the value for the real input is a long number. So you have to have a long number. Yeah. So then we do a kind of for each var line in lines. We parse the line into a long. Then we want to write the method to do the actual calculation part. So we do a kind of a static long. Yeah. So yeah. Copilot remembers my code. That's good. Yeah, so we can revise this. So here we have the number. We take the number XOR the number multiplied by 64, then do the pruning. So we do it all in one kind of. So all these rules will be done in one line. The next thing in the sequence will be always do the mixing part, which is the XOR. Then we do divide it by 32, and then we do the pruning part, modulo this number, and also for the next thing we multiply it by 2048, modulo this number. So that's actually all that's to it. And when we execute this, we will get let's check if we have the right 37, 32, 76, 23. Yeah, so that's I think was yeah. So that gives us our part 1 answer. Then we have the part 2 of this problem. So the part 2 of this problem is not that much more complicated, at least not to understand. But we can read here that. Yeah, so we check the text here. So of course the secret numbers aren't the prices each buyer is offering. That would be ridiculous. Instead, the prices the buyer offers are just the ones digit of each of their secret numbers. So if a buyer starts with a secret number of 1, 2, 3, that buyer's first 10 prices would be 3, 0, 6, 5. Yeah. So basically the ones digit will be the secret number modulo 10 will be where we get this number. So this price is the number of bananas that buyers is offering in exchange for your information about new hiding spot. However, you still don't speak monkey, so you can't negotiate with the buyers directly. The historian speaks a little but not enough to negotiate. Instead, he can ask another monkey to negotiate on your behalf. Unfortunately, the monkey only knows how to decide when to sell by looking at changes in price. Specifically, the monkey will only look for a specific sequence of 4 consecutive changes in price, then immediately sell when it sees that sequence. So if a buyer starts with a secret number of 1, 2, 3, that buyer's first 10 secret number prices and the associated changes would be, so we start by 1, 2, 3, that will be 3, and modulo 10 will be 3. This is the next secret number in that sequence. Modulo 10 will be 0, so that will mean the difference here will be -3. Then the next number in the next secret pseudo-generated number, so to speak, will be this, and modulo 10 will be that. Then it will be a difference of 6. Then we have kind of because we go from 0 to 6. Then the next one will be 5. Then we take then difference between 5 and 6 will be -1. This will be 4, so it will still be -1. Then it will be the same, so it's 0. Yeah, you probably understand how it's going to be. So continue on, and note that first price has no associated change because there was no previous price to compare it with. So in this short example, within just these first few prices, the highest price will be 6. So it would be nice to give the monkey instructions that would make it sell at that time. So the first 6 occurs after only 2 changes. So there's no way to instruct the monkey to sell then, but the second 6 occurs after the changes -1, -1, 0, 2. So if you gave the monkey that sequence of changes, it would wait until the first time it sees that sequence and then immediately sell your hiding spot information at that current price, winning you 6 bananas. So each buyer only wants to buy 1 hiding spot. So after the hiding spot is sold, the monkey will move on to the next buyer. And if the monkey never hears that sequence of price changes from the buyer, the monkey will never sell and will instead just move on to the next buyer. What's worse is that you can only give the monkey a single sequence of 4 price changes to look for. You can't change the sequence between buyers. So you're going to need as many bananas as possible, so you'll need to determine which sequence of 4 price changes will cause the monkey to get you the most bananas overall. So each buyer is going to generate 2,000 secret numbers, and after their initial secret number, so for each buyer you will have 2,000 price changes in which your sequence can occur. So suppose the initial secret number of each buyer is, so this is, we are going to actually replace our example input here, because they will change between part 1 and part 2. So there are many sequences of 4 price changes you could tell the monkey, but for these 4 buyers, the sequence that would get you the most bananas is -2, -1, -1, 3. Using that sequence, the monkey will make the following sales. So for the buyer with the initial secret number of 1, changes -1, 1, -1, 3 first occurs when the price is 7. For the buyer with the initial secret 2, changes -1, 1, -1, 3 first occurs when the price is 7. For the buyer with the initial secret 3, the change sequence -1, 1, -1, 3 does not occur in the first 2,000 changes. And for the buyer starting with 2824, changes -1, 1, -1, 3 first occurs when the price is 9. So by asking the monkey to sell the first time each buyer's price go down 2, then up, then down 1, then up 3, you would get 23. So it will be 7 plus 7 plus 9 bananas. So figure out the best sequence to sell the monkey so that by looking for that same sequence of changes in every buyer's future prices, you get the most bananas in total. So what is the most bananas you can get? So let's do that. So we have our code here. So in this sense, we want to kind of track our the sequence of these price changes, and also keep kind of a tally of the largest or the maximum price for those. So when I first read that part 2 statement, I initially thought it was going to be a bit complicated, but it actually wasn't that complicated at all. So we kind of do a dictionary of. So this dictionary will contain kind of the 4 price changes, and then the maximum price for those. So we need to check in that order. So what we're going to do is to again loop through the lines, and we will basically do the same thing as in the part 1. Oh. And so we will keep kind of a local list of buyers, or actually a buyer. So we will kind of take initialize it with the initial number modulo 10. So we get the first kind of, if we check the statement here, that you can look at it as like this. If this was the first number, then its modulo 10 would be 3. So that's our initial state. So then we need to kind of get 4 other price changes after that. Then after this we're going to do our now it seems my ending bracket has disappeared. Yeah, so now we're going to do the for the 2000 kind of so instead of doing 2000 for the same, we will actually add. So we will add that number. So we kind of collect 2000 price changes for this buyer. Then just so that so that we don't actually check for the same price changes again and again, because that was, I mean, mainly this problem was to get it so it wasn't actually implementing this logic, because it's not that complicated, but mainly it was that performance could be really bad if you do this in a more naive way. So, and I'm not completely satisfied yet with my solution, and I do think you can do it, make it go even faster, but I haven't done more optimizing with this. So yeah, we will see. So yeah, we let Copilot do the coding for us here. Yeah. So so what we do here that we get kind of we loop through the buyers. We create a sequence. So we go kind of, we take the current, we go 5 or 4 indexes in front of us. Then we will stop when the count is -4, so that we don't kind of pass over the length of the list. Then we will create our sequence, which will be kind of as normal here. We take kind of A, B, C, D, and E. These are all kind of prices or price. Well, that is the modulo 10. The one digits, which will be the prices. So we will kind of log the changes here. So we will take kind of B minus A, C minus B, D minus C, and E minus D. So that will be our sequence that we are also storing in our scene set here. So we check if that sequence has already been seen. We're not considering it, so we just move on. If then if it's not been seen, we add it to our scene set. And we also have kind of our sequence to total, which will be kind of this sequence, and then we kind of add the last price in that sequence. We will kind of add our total to. And yeah, and that is basically the entire solution. And at the end, what we do is to just take the maximum value of this dictionary, and that will be our kind of highest price, and that will kind of also tell us how many bananas we can buy. So let's run this. And for this example data, it runs quickly. And if we just go here, we can see, okay, that's interesting. It should be 23 actually. Yeah. Oh, yeah. I didn't actually switch the testing data. Yeah, so when doing this, we should have the correct result. Yeah, 23. Yeah, that can be a little bit confusing that they change example data between part 1 and part 2. So that will be our part 2 answer. If we just check, if we just take my real input, and I can just show you that the performance will be a little bit lagging when doing this big input, and there are still kind of performance boosting you can do. You see, it takes a little bit of a time to execute part 2. It's not more than 1.5 seconds or something. And I kind of spent a little bit of time trying to make this go faster, but well, I don't think it's that necessary. So that will be our day 22. And yeah, I can say I was a little bit disappointed in this puzzle. It doesn't actually feel that this is a day 22 if you talk about the difficulty level of it. So maybe they actually thought that because yesterday's problem was so hard to do, maybe they thought that, well, they could give us something a little bit easier today. But the biggest thing, I guess, is the cheating going on with people using LLM tools to get on a leaderboard. I think this is not a problem that LLM tools will have a problem with at all. So that's a little bit disappointing actually, because now I mean now we only have 3 days left, and we have not had, well, I mean there have been, I think, 2 or 3 this year that has been really, really difficult days, and yesterday was such a day. But I do think that it has been significantly easier this year than last year. Yeah. Okay. Yeah, that's me rambling a bit about this, but I do still think this is really fun, and I mean, even if this puzzle was pretty easy and went by really, really fast, I do think it's fun to do these puzzles once in a while. But for the entire competition, in that sense, I think a day 22 should be harder. Yeah. So I'll see you back tomorrow then, on day 23. So bye bye.